Okay, today, since we finished all the conceptual stuff of static electricity, we're going to move on to the practical stuff, all the equations and such. So when we're talking about static electricity, we measure this in coulombs. Coulomb is the quantity of electric charge that something has. 1 coulomb, there are 6.25 times 10 to the 18 electrons for 1 coulomb. That's a lot of electrons. Shows how small we are. Or you can write it this way: 1 electron equals 1.6 times 10 to the minus 19 coulombs. So that's the charge on 1 electron, 1.6 times 10 to the minus 19 coulombs. You know, abbreviate coulombs with a big C. We'll get there. So Coulomb's law: the force between two charged objects vary directly with the product of their charges, and inversely as the square of the distances between them. This is basically just words for an equation that looks like this. F equals K, which is Coulomb's constant, times the charge of the first object times the charge of the second object, divided by the distance between them squared. Now this equation here looks a lot like another force equation that we had, the force of universal gravitation from Newton, where this was big G, M1, M2, and the distance between them. Very similar. So here force is measured in newtons, Q is the charge measured in coulombs, there's that big C, and K, which is a constant, always equals 9 times 10 to the 9 newtons times meters squared over coulomb squared. These units are important for this because whenever we do K times the rest of this stuff, the M squared is going to disappear because we have M squared on the bottom here, and the C squared are going to disappear because we have C squared on the top here. It's coulombs times coulombs, we'll get the C squared. So these cancel out and leave us with just newtons for the force, which we all know force is newtons. And just like Newton's law of universal gravitation, this is also an inverse square law because we've got the squared meters there on the bottom. That makes it inverse and squared. So easiest way to do this part is just to do problems. So find the force of attraction between charges of 100 microcoulombs. Micro means times 10 to the minus 6. So that's 100 times 10 to the minus 6. And negative 50 microcoulombs, separated by a distance of 50 centimeters. Now you can leave the units in microcoulombs, and now you should probably convert it because our units for K are in regular coulombs. So we have our equation, and when we write this all out, we convert the microcoulombs to regular coulombs. So the charge 1 is 1 times 10 to the minus 4. The charge 2 is minus 5 times 10 to the minus 5. You've got to make sure you have that minus sign in there. Distance between them, 0.5 meters, and K is always K. So remember that K. So you plug all these into your equation here. Here's the first charge, Q1, Q2, the distance squared, and here's K. And you'll get an answer, which apparently I didn't put on here. But plug it in your calculator and see what you get. No, I did put it on here. Here's the rest of it. So you plug all this in your calculator, you get negative 180 newtons. So the negative sign means there's a force of attraction. So these objects are going to be attracted to each other, which is obvious because this is positive, this is negative, and we know that opposites attract. Here's another quick little problem. Two charges are separated by 4.0 centimeters. Object A has a charge of positive 5 microcoulombs, and B positive 3 microcoulombs. What is the net force on object A? You write down your equation. You write down what you know. Like I said, this micro means times 10 to the minus 6. So 5 times 10 to the minus 6, 3 times 10 to the minus 6. The distance between them, you got to make sure you convert it to meters. We don't like centimeters. Make sure you convert it to meters. 0.4 meters. We have to convert it to meters and regular coulombs because we have meters and coulombs for our K. If you don't, you're going to get a weird force. So we plug all our stuff in there, just like the last problem. And just like the last problem, you put all that junk in your calculator, and you get a force of 84 newtons. Now this is positive 84 newtons, which means it's a force of repulsion, which is conceptually obvious because this is positive, this is positive. We know that like things repel each other. So it's going to be a repulsive force. Here's one for you to do for yourself. You should press pause right now and do all this stuff. So a positive charge of 3.5 times 10 to the minus 6 coulombs has two charges nearby. One has a negative charge of negative 1.2 times 10 to the minus 6 and is 0.3 meters away at 180 degrees. This second charge is a positive charge of 3 times 10 to the minus 6 coulombs at 270 degrees at 0.02 meters away. Now what these degrees here mean, it shows like which direction from the original charge the other two charges are. So what is the total force on the 3.5 times 10 to the minus 6 charge? Maybe you shouldn't do this one on your own. Maybe I should just show you it. So you want to draw it out. So the first charge said was 0.30 meters away at 180 degrees. So we take this to be our 0, go all the way around to 180 degrees. So that's where we put that first charge. Second charge is at 270 degrees, which means we go all the way around here, 270 degrees later, and it's 0.02 meters away. So you always want to draw a picture whenever you have more than one charge, so you know the orientation of the charges. So we know that the force supplied by the first one is going to be an attractive force. So this positive charge is going to want to move this way. So that's why we draw this regular arrow here. So here's your F1. So the charge between this positive and this negative is your F1. And it's going to be going this way since they want to attract each other. Now for F2 is the charge between these two positive guys. They're going to repel each other. So the force is going to want to push this guy upwards. So that's why we have the arrow going this way. And we want to find the combination of these two forces, which we know is going to result in something like this, which we should remember from like one of the very first chapters we did. So let's just do this problem. Force 1, we know the charge of the original guy is 3.5. We know, forgot a negative sign in here. Oh well, don't forget to put a negative sign in there. So here's the two charges, their magnitude, the distance between them. So you plug that in, and you get you get 42 newtons. And it should be negative. So negative 42, but that negative sign just means it's going to the left, so maybe that's why I left the negative sign out. And for the next one, it's going up, so we know it's going to be positive. Plug our stuff in. Here's the first charge, the original charge. Here's the charge that's below it, pushing it up, and the distance between them. So you plug that in your calculator, and you get 236. So now you can redraw it. Force 2 equals 236 newtons up. Force 2 equals 42 newtons to the left. And then we use our trig stuff. I know how you all much love the trig stuff. And you're going to get a resultant force that looks something like that, which is just the hypotenuse of a right triangle formed by these two sides. So we use the, I can't remember the name of this equation. It escapes me right now. A squared plus b squared equals c squared. Why can't I think of the name of that? Somebody help me. I forget. Wow. Drawing a blank. Monday morning. Oh well, we'll forget about it by now. A squared plus b squared equals c squared. And you do 42 squared plus 236 squared equals 57,460. So that equals our f squared. So we take the square root of this guy, and we get 240 newtons. So this f equals 240 newtons. And we can find the angle, the tangent of 42 divided by 236. If you're in radians, it'll give you 0.178. And if you're in degrees, it'll give you 10 degrees. So that 10 degrees is going to be the angle right here. So we know that if we have a coordinate axis here, that from here, this line here, to this line is 90 degrees, plus this additional 10, so it's going to give us 100 degrees. So you could either say the force on the 3.5 times 10 to the minus 6 coulombs is 240 newtons at 100 degrees, Or you could say 10 degrees west of north, or you could say 80 degrees north of west. Either way, we'll give you the right answer. Here's one you should do on your own. Got some microcoulomb stuff. You want to convert to coulombs, and your distances are given in meters, so you don't have to convert anything there. So a negative charge of 4.5 microcoulombs has two charges nearby. One has a negative charge of 1.2 microcoulombs and is 0.4 meters away, 90 degrees, and the second charge is a negative charge of 2.1 microcoulombs at 180 degrees at 0.03 meters away. So you want to find the total force acting on the 4.5 microcoulomb charge. So we draw a picture. Here's our original charge. These guys are all negative, so they're all going to repel each other. So that means when we redraw just the forces on here, we're going to have an arrow going this way and an arrow going this way, just like that. Because this guy here wants to push this guy to the right, so force 1 goes to the right. And this guy here wants to push the original charge downwards, so that's how we have that. So you plug in your numbers. You don't have to worry about negative signs here because we already have it taken care of with the directions. You plug all your stuff in for force 1, and you get 95 newtons. You plug all your stuff in for force 2, and you get 30 newtons. So force 1, 95, force 2, 30. We're going to get a resultant that kind of looks something like that, just like I said. Then you use that equation that I cannot remember the name of because it's a Monday morning and I don't drink coffee and I'm tired. And you get 9,736 newtons. Pythagorean theorem, I remembered. Eureka. Square root of that will give you 99 newtons. And you want to find that angle, this guy right in here. If your calculator's in radians, you get 0.315. If it's in degrees, you get 17. So you get 17 degrees here between this positive x-axis and a resultant. And you can write that a number of different ways. Just make sure you indicate what it is. I prefer to use it the old-fashioned way where you go completely around the circle in the end right here. So 360 minus 17 degrees will give you 343 degrees. So this entire angle, one rotation from your math class, is 343. Or you could just say 17 degrees south of east. And that's it. Enjoy the rest of your evening.